thank you, and it's great to have folk here as well. I hope this is an interesting session. I have been looking forward to talking about this for, I don't know, months. Normally my job, as some people know here, is I lead and cursor management and scrolling and all kinds of interesting things like that. You kind of wind up after a couple of hours with a text editor that looks like this. And I thought, well, that's kind of cool. The world needs more text editors for sure. Yeah. But it felt a bit boring just to kind of follow it through in C. So I thought, well, let's do the same thing in Dart code. I'm a Dart person. That's my thing. By the way, if you've never done any console programming before, it's like going into an alternate universe that hasn't moved on since about 1968. When you write console code, what you actually wind up doing is you send ANSI escape sequences. So the way you do things like move the cursor to the start of the line or move to the top of the screen is to send a VT escape sequence. These VT escape sequences come from this computer, fresh out of the Computer History Museum. This is the VT100 terminal that came back a long way. So there's an example. This is a bit of code from Kilo. If you want to move the cursor to the top 00 coordinate to start drawing the text editor, you send this bit of code to the screen. There's this like sort of bizarre looking sort of spurious bit of code here, and the \x1b means send escape sequence control code. I think it's number 1b in decimal 26. It's the escape code, and then an open bracket, and then you pass some parameters that actually say what to do. So you hide the cursor with the top one. You go home by sending that second line, and that works in any modern terminal these days. It works on Unix, Linux, Mac, Windows the same way. So that's the kind of code that you write. But again, that works in Darts fine. But I did hit one problem as I was going through this process. And there's something you have to set up when you're creating a terminal editor, when you're writing stuff like this, where you need to turn off a whole bunch of standard things in the terminal. For example, you don't want Control-C to be trapped. Like you don't want to hit Control-C when you want to sort of copy something to quit out of the program. You want to be able to trap it by the app itself. There are other things like that you might want to do. You might want to hide the cursor. You might want to set up things like, let me think, sort of set a consistent, like what happens when you hit return, so it doesn't set the whole thing across. And so this is like this really nasty blob of code in the C code that does all this work to set up the terminal, and very Linux or Unix focused. And I needed a way to do that from my Dart version of this code, as I was taking this Kilo text editor and writing the same thing in Dart. So how do you do this? Dart actually has a couple of these properties, but doesn't have the full thing. And it turned out that about the same time that I was doing this work, there was an introduction of a new feature in Dart 2.5 at the time called FFI, or Foreign Function Interface. And FFI is basically a way from Dart code to say, I want to talk to the native system libraries, or I want to talk to other C code that I've written, the DLL in Windows land, or a .so, or a dilib in Linux or Mac language. And so that's what I did. I used this FFI feature to do this. So again, in Linux world, in Mac world, this is what you do. You write this sort of rather nasty set of things, and you call this method tcsetatra to go and pass this to the terminal. On Windows, it's slightly different because Windows is different. And there's a couple of API calls in the Windows kernel 32 library. You call get std handle to get the std in stream, get console mode to get the current mode, and then you can twiddle some bits for things like, does it echo the input back as you type individual letters? Does it trap Control C or not? And then you just set that back in. So that was what I was trying to do in my Dart code. Got it? So a bit of a diversion, but that's how I got to this place where I was like, I want to write some Windows API calls from Dart. So the good news is there's a really this FFI thing is a really good way of doing it. And so I want to just talk a little bit about how you go about doing that kind of thing. This is like a very, very simple C call here. And I just use this for didactic purposes here. So what you see here is it's adding two numbers together, right? I take two int variables that are 32 bits in width. I add them together and I return them. So if I wanted to call something like this from Dart code using FFI, here's what I do. I start off by writing this little bit of code here that maps the function prototype onto the equivalent Dart concepts. So there's two of these type function definitions. The top one is using Dart FFI, and it basically says to the Dart FFI environment, think of this as a function that takes an int32, a native 32-bit integer variable, in fact two of them, and returns back another one. And then the second line is the Dart version of that same function prototype. And what this does is say, okay, of course, it's two ints. And so that's the first thing you do. You just declare, here's what the C function that I want to call looks like for the FFI world. And here's the Dart equivalent. And then all you do is you take that and you add a little bit of code that maps those two things together. So here's my main code for the Dart code. And so what I've got here is I'm opening the library. In this case, this is the DLL that I've created, this mathlib.dll. And then I'm saying to this function, I need the add export from that function. And the way that you should think of this function is here's the native version and here's the Dart version. So whenever you're calling FFI code, this is the main thing you're doing. You're just mapping, here's the C version of it and here's the Dart version of it. And then you can call it. So let me show you something a little bit more sophisticated there. And I want to actually show you like a real world sort of example that maps onto this Kilo thing. So here's those three method calls that I was talking about earlier, getting the standard handle, getting the console mode, and setting the console mode. And in the quotes here, you'll see or in the comments, sorry, you'll see the C prototype. If I was to look in the Windows API docs or the header file, these are the three methods that I'm calling here. And you can see that each of those has their own sort of types associated with them. A handle in Win32 world is an int pointer type. In other words, it's the same width as a pointer on the system. So on a 64-bit system, that's a 64-bit int. On a 32-bit environment, it's a 32-bit int. And so we declare that as an int pointer, which is again the way of saying I want one of those in the Dart world. And if I just hover over that, you'll see that a little bit of help that comes from that. That's a class that comes from the Dart FFI library. So that's again how this is specified. And similarly, the int32 one, same thing here. This is a 32-bit integer in C. And so I've got one of those definitions for the C side of the world
in my code. And then I've got one of those definitions in the Dart side of the world that represents the Dart equivalent. So when I call this function, this is the Dart prototype for it. And then here is simply the lookup that says to Dart FFI, go and find the symbol, the exported symbol from the DLL called getStudHandle, and here's the C prototype, and here's the Dart prototype. So hopefully that makes sense. It's fairly sort of simple. It's a mapping from one thing to another. So I declare those things. I've got a couple of constants that, again, come straight out of the Windows documentation or from the Windows header files. And I took this to create this raw mode for Dart. So I built this as an extension method on the stdin stream, which is something you can use in Dart. And I simply created a setter property here called raw mode. I took a slightly simpler version here just for tutorial purposes, but here's what I'm doing. Now all I can do is I can actually call those Win32 functions, having set that stuff up there, just like that they were any other functions in my code. So now I can do getStudHandle for the input, meaning get me the handle for the input stream, and that gets put into the stdin variable here. And then if I say I want to go into this raw mode, if I want to turn off Control-C processing, if I want to turn off console echoes and things like that, then I call it with this version. And if I turn raw mode off, then I call it with this version, which simply turns a whole bunch of these things on again, echo input and line input and things like that. So I can now go and run that. I can use something like this code here. And so having sort of created all that sort of FFI gunk, now I can kind of use it in a fairly idiomatic Dart way. So here's a simple console app. I enter some code text. I take some input from the screen, and I spit some results back out again. Oops. And I can also go ahead and I've put that in the wrong place. I can then turn on raw mode and do the same thing again, and have that work for me. So let's go and run that here. That's raw test. So I'll go to FFI demos raw test dart. And let's move this over here so you can again see the code. So I'm in normal mode right now. This is what I get with any sort of standard thing here. So I can type in some text here. You see it immediately being echoed back to me from Dart. And when I hit enter, it's going to give me the results. Now this gets set into raw mode. So now I'm in raw mode. Now if I start typing text, you can't see for sure, but you can trust me that I'm typing text here. I'm going to press Control-C, and it doesn't sort of quit out or anything like that. I can type some more text in, and it's giving me the results in raw mode. So that is the last thing I need to do to turn Dart into this fully capable sort of environment. And that's the kind of thing you can do with FFI. There's a few other things I should quickly sort of mention with FFI. One thing that you often need to do is work with pointers, which is a very standard C concept. So if you've ever got sort of things in C, you need to declare something and you need to allocate memory. And so FFI contains a whole bunch of features for doing that kind of thing. There's something called calloc, which maps onto the C sort of equivalent of the calloc or malloc, is sort of methods for allocating memory in native space. So you can create one of those. You can pass memory that is unmanaged memory essentially to the C unmanaged world and have it do things and have it freed up at the end when you do things on the other side there. So having done all of that work, now I have something I can actually use to build this Kilo text editor. Again, here is the 1,000 lines of C code that does the text editor. And here is the Dart version that uses these commands and lets you do some fun sort of edits, and it handles things again like Control-C and things like that. So let's just see this real quick, just so you can see that I'm not lying. FFI demos, oops, Kilo, I can't type this morning, kilo.dart. And drum roll. There we are. There's my Dart full screen text editor. So I can, here's some text for FlutterVikings. I can type some text in. I can press Control-C. I can press other sort of keys. I can move up and down. I can insert rows and things like that. And it all handles everything that I might want to do here. I can save code. I can try and exit, and it gives me sort of like the question messages. And then it comes back out of Dart mode again at the other side. So Dart full screen text editor. Vi is now obsolete. We now have the Dart equivalent. We can now move forward. So good start. Hopefully you think that's quite cool. So next stage. So that was all very well. I thought, let's take that and let's create a package that encapsulates all that raw code mode stuff. Nobody should ever have to write that code again. That's awful, like FFI, grungy stuff. We should encapsulate the heck out of that so that everybody else can just use it. And so I wound up creating a package called pubdev / Dart console. Not Drat console, Dart console, there we are. And Dart console basically encapsulates that and a whole bunch of other features that enables you to do control sequences, enables you to do sort of like cool colors and things. In fact, let me just show you that. I'll just go to the Dart console thing here and I'll show you, speak an example of this. Since I did it in Windows mode, I also did the equivalent in Linux and Mac sort of equivalents using the tcsetadr and other things there. So this works across all platforms, offers the same features on each. So I've got all kinds of like fun little demos that show things like setting different ANSI colors, setting italics and bold and aligning text and extended 256 colors because every console app should be ludicrously bright and colorful and include power line scripts and things like that. I've got some basic table stuff that I'm still working on here, and little sort of fun things like sort of random plot at sort of 3210 a specific point or something like that. So that's Dart console, and you can take that and use that for whatever you want if that's useful to you, and that's sort of like a fun little example of this. But Windows lets you do so much more than that, of course. It's got thousands of APIs that handle all kinds of different things that you might want to do. And so some examples that are here, right? You can, you can enumerate all the hardware on your machine. You can print stuff. You can call Bluetooth. You can find all the serial port connections. You can take credentials and save them to the local store. You can find all the fonts. You can write to the registry, all the stuff that you typically want to do with Windows. And so I thought it would kind of be fun to kind of take some of that learning that I had from the console thing and see what else I could do with Windows using that same set of things. So, it turns out I can just do the same kinds of things. And so if I go to, let's go back to this folder again. And let's have a look at this one here. Message box seemed like a really simple thing to want to go to do, to be able to print out one of the classic Windows message boxes. Anybody who's using Flutter to do Windows desktop apps today probably knows that Windows doesn't yet support multi-windows. So if you want to just do a nice little dialog box, that kind of thing can be a little bit painful to do today. But with this, you can use the Windows APIs to just go and print a Windows message box. So it's exactly the same model here. We've got this thing called message box, which is a standard Windows API call. You pass it the message and the title and whatever buttons you want, and you get a response from that. And if I browse into here, I'll give you a little bit of a preview of the message prototype here. Again, it's just the same kind of thing. I've got here these different prototypes. I've got the FFI prototype. You'll see again int 32s and int pointers and pointers to Unicode text. And then I've got the Dart equivalent here, and I can take that wrapper and call that from this API here. So in this case here, I'm just using a simple bit of code here. I'm taking a string. I'm saying give me the native unmanaged pointer to that string, so I can go ahead and use it from Windows World. And then I pass it to the message box API and say, hey, go and print this. And then when you're done with it, I get the result of the message box, and I free up the associated stuff. So now I can go ahead and call. What was it called? Dart FFI. Oh no, wrong folder. Dart message box dot, and here we go. Brace yourself. This is the coolest demo you will see all day. A message box. Again, I want to kind of make sure this is clear. There is not a single scrap of Flutter code here. This is all Dart, right? So I'm just using the Dart calls to the Windows APIs to print out, in this case, a rather unimpressive menu box. So I can choose an option there, and I get a response coming out of that. So okay, cool. That's kind of fun, but as I mentioned, there are all these other sort of things that I can go ahead and create. So I wound up gradually over time building up all these FFI mappers of function call to the sort of the Dart equivalent. And just like the Dart console thing, I wound up just putting it in a package, right? It makes sense to sort of store these things. I shouldn't have to write those every time I use them. Let's just create a package that contains all those FFI mappings. And so that package became something that I call Win32, which is essentially the Dart library for all of this random stuff. And what Win32 does is simply has this set of all of these FFI mappings for thousands upon thousands of Windows APIs. And so if I scroll up here a little bit, I'll get rid of some of this stuff so it's not blocking me. And let's go to kernel 32, which is like one of the standard sort of like core functions in Windows. And you can see here as I kind of scroll up and down here, thousands upon thousands of lines of all these different mappings to different Windows APIs that are now available to Dart code. So, if I've ever had a hankering to get the number of processors on the machine that I have, I can call this function and get that from my Dart or Flutter application. Really useful stuff there. But lots and lots of these different things. You might worry a little bit. You might think, well, gosh, there's thousands of stuff. How much bloat is all this? But don't forget that Dart does this thing called tree shaking. So whenever you compile an app, anything that's not actually called from your Dart code just gets thrown away. We don't compile it into the app. So it doesn't matter that there's thousands upon thousands of these definitions. They're just available to you in case you want to use them. And so the way you use them is you just import this Win32 package, and suddenly all these Windows functions appear to you. And you can use them to either build directly Windows stuff, or you can build a package that does things in Windows and Mac and other things and just sort of like squirrels them away in different places. So now I can do some really fun things. Now I've got this. I started playing around with just different examples. I wound up grabbing different things from different classic Windows programming books from years ago. I don't know how many of you have heard of the book by Charles Petzold called Programming Windows. This is like the test of people who are over about 40 years old, I think. This is like one of the classic books on programming Windows that dates back to the 90s, and it's basically just how to write sort of Windows apps. And one of the most basic sort of apps he writes is like a hello world that shows the whole Windows sort of message loop. It's more than just printf, I promise you. In fact, here is the Dart version of the Petzold Hello World app, and it does a whole bunch of rather sort of painful things that today we probably wouldn't consider very friendly, but is sort of just fun or sort of very direct ways to call into the Windows API. So it creates a window. You see here is the call in Windows World to create a window, and you can set things like the caption of the window, the title, what kind of window style, where it is, what its parent window is, etc., etc. And then there's a message loop, just like if you're a games developer, you know about the games loop. It's the same thing in Windows. When it really comes down to it, there's this loop that all the time is checking for new messages, like I've moved the mouse or I've typed a key, and this dispatches it to a message catcher. And here's the message callback that actually handles those things. And in this case, this very, very simple app doesn't deal with things like mouse or keyboard. It just prints a message that responds to this paint screen message here, and so it takes the text message and draws that to the screen. So let's just show you that one. To the right folder, and we'll go and grab that one here. Again, brace yourself, this is a crazy cool demo. It's a blank window with the words Hello Dart in it, but this is again all done purely through Dart, just through calling these underlying system APIs. And know this because it will come back a little bit later on. Everything that I'm doing here is actually what goes on behind the scenes when you create a Flutter app. It's just that it's not exposed to you. Behind the scenes, Flutter has C code that does all this stuff of setting up a message loop and dealing with incoming things. But that's like a really basic example. But of course, there's more clever things you can do once you've sort of figured that out. And I thought that was kind of rather cool that I could sort of take, like the whole Windows process and just do it purely from Dart. I don't know what I thought I was doing at the time. Maybe I thought I was going to create a competitor to Flutter whilst working on the Flutter team. But anyway, it was kind of a bit of fun. But I took some of the more advanced samples. There's another sample right at the end of this Programming Windows book that basically shows you how the Windows Notepad app is created. So I'm still stuck in this editor world. I can't get out of it. I've done my console editor. Now I'm like, okay, let's create a Win32 editor. So That's what this example does. So if I go here and run notepad.dart, you'll see here something that looks, if you've ever been a Windows user, very, very familiar to you. This is Notepad, but it's not your mother's Notepad. This is real Notepad written in Dart. So every line of code that you see here is written in Dart, not Flutter, just Dart. So I can, again, sort of start playing around with this, and I can do things like I can change the fonts. And so what I'm doing here, when I do this, I'm calling the Windows common dialog box that says, give me the font dialog chooser. So I can pick, a font of my choice, and I can change, whether it's bold or semi, whatever. I can sort of start typing more code here or more text here. So really, again, now, I mean, not only Vim is obsolete, now VS Code is obsolete. I can now do everything using Dart Notepad, and I can do things like I can save files. I can sort of do all the usual things that I might want to do with a notepad. So really kind of cool, this control paste, cut and paste all works, that kind of thing as well. So everything that you see there you can do. So building up the kind of layers here, the things you can do with Dart. I thought it was fun to go a little bit further. I found an example which was Tetris, and I thought that's kind of fun too. So I thought, well, we'll try and do Tetris with Dart. So this is using another part of the Windows API called GDI that is like drawing things on the screen. So now I really am competing with Flutter, but this is sort of Tetris written in pure Windows code. And again, like just to be really clear, this is not Flutter code. This is just Dart calling into the Windows APIs. And if I was to kind of quit out of that for a moment, I could compile that using the usual sort of Dart compile commands and wind up with an exe that is Tetris.exe. And all I'm doing here is taking that code, compiling it, and there's my main.exe. Let's call that. Should give it a really good name, shouldn't I? It's in the example folder. Never mind. I'll just go there and show you the file. And there it is. It's not the smallest executable. There's a whole bunch of stuff that we're doing. It turns out that Dart was never invented to be like a 1990s Tetris compilation engine, but it's still kind of pretty functional from that point of view. And there's a bunch of other examples in this folder. Okay, so next layer up. So I've got all those thousands of C functions that I can go ahead and do stuff with. But at some point in the Windows world, they decided we're getting too many of these functions. We need some way of cataloging and sort of managing them better. And so Microsoft invented this thing called COM, or the Component Object Model. And COM is basically a way of bringing components or object orientation to the Windows world, and sort of saves this sort of problem of just this exploding number of different APIs. There are two things you need to know about COM. Firstly, COM objects are basically just collections of a bunch of methods into an interface. An interface is simply COM's way of defining something you can go ahead and access. So in COM, what you do is you basically say, I need this object, and I want to use this interface on this object. And COM gives you this activated object that you can just go and call methods on it, just like if it was any other class. Second thing you need to know about COM is that every single COM component has one common interface. So you always know when you've got a COM object, there's this thing that you can call, and it's called IUnknown. And that basically is the sort of like the anonymous interface. It's the interface you can guarantee that every COM object has. So same way in Flutter world, you think, well, everything is a widget. In COM world, everything is an IUnknown. That's kind of how you know where you're going with COM. Now, I'm going to get a little bit deep into the weeds here, but just bear with me if you're kind of reaching the end of your sort of patience with this stuff. I'll come back to a demo or two in a second. But if I was to take a COM object and blow it up and kind of look under the hood, this is how it's actually constructed. One of these interfaces that you see is actually in under the covers just what we call a vtable. It's a collection of functions or pointers to functions. And so when I go ahead and need to get at something in the COM world, I get this thing which is a vtable pointer that basically is like the pointer to the table of functions. And let's say that this, I've got an object that is something like the file open dialog box or something like that. That's a good example of a COM component. I can take that object, I can interrogate it for the file open dialog interface, which is called iFileOpenDialog, cleverly enough. And I can then look at it and poke inside. And there's like, I don't know, 40, 50 methods that are available that are inside that interface. And I can use that vtable pointer to basically find a list of these things. So if I was to look at the code or look at the memory, what I'd see is 50 or 60 pointers, one after the other, each of them representing one of the methods on FileOpenDialog that I could call and use to get at different things. The first 3 of those methods are always the methods from the IUnknown interface. So I always know I can get at other objects. I can always do some standard things that are associated with the IUnknown interface. There's one called query interface, which says I want another interface. There's an add ref and release that are about reference counting, basically sort of saying I'm using this, I've stopped using this. So that's what goes on behind the scenes with COM. And again, the end of the day, for as complex as all this sounds, and there are again books written in the mid-90s that contain swathes of information about this, at the end of the day, it's just functions. And so if I want to write Windows code that has COM components in it, or I want to use COM components, then I just need to kind of unpack all this stuff. So that's what I did, because I'm sort of have this sort of rather challenging thing that I don't know where to stop. That's if I go back to, let's go back to the FFI demos folder for a moment. Where are we? That one there. And look at this dialog example. This gives you a little bit of an example of how to write COM code from Dart. And again, if you are somebody of a certain age like myself who grew up as a Windows developer, this code will seem very, very familiar to you. This is just the same kind of code that you would have historically written in C or C++. So I call this method to initialize COM. That's like a standard thing. And then you see here what I'm doing is I'm just saying, give me one of these FileOpenDialog objects. And there's my interface, iFileOpenDialog. If I take a moment and browse into that, I can see here is the interface. In fact, I'm just going to go up a couple of layers here because this interface inherits from other interfaces. So if I go right up to the top here, this is the code for modeling the IUnknown interface in Dart. So this is my how I get to that function vtable and do all that kind of crazy stuff here. And again, you see that ultimately it's just the same stuff. I've got this prototype and I'm just calling into each of these different methods. So this is IUnknown, but IUnknown is inherited by something called modal window, which all modal windows contain. And then that's inherited by something called iFileDialog, and that's inherited by something called iFileOpenDialog. And here you get a sense of this vtable sort of mentality. And again, I promise I will bubble up in just a second here. So here, this is the 4th entry in the vtable. This is the 5th entry. And all I'm doing with each of these items here is I'm saying, OK, look up that vtable. This method here, in fact, let's just find the show method just as an example here. Show dialog, what's it called? Can't remember what it's called. I thought it was called show. Blah, 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 blah. Well, you get the idea. There's lots of these different things here. If I want to pick one of these, I go, oh, shows on modal dialog. That's fine. Let's say I want to change what the title of the dialog box is. It's this one here, set title, and this is the 17th entry in the vtable. And I can take that pointer and then turn it into a function that I can call from Dart that is called set title. So eventually, you kind of wind up with this thing that I can use. And here you see that I'm using that from within my code here. I've got this file dialog object, and I'm just calling show on it. And if I get a result, then I can find the name of that by finding another object and blah, 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 blah. So let's just call that. And we'll go here, and we'll call dialog show.dart. And this is showing you just a really basic sort of like FileOpenDialog from the COM world here. So, so you can see here just like, the standard stuff that you get in Windows from any other piece. And I can pick an object of my choice. I can go and find a file. I'm sure I've got a file somewhere on this entire system. Let's go and grab some random file here and click OK. And hopefully the command lines come back with the location of that file. Again, like the whole point here is not that that you want to be writing this code on a daily basis, but you want it to be available because then somebody can take the code and write a nice wrapper that is like a file picker for Windows that uses this code and doesn't require you to do a whole bunch of C++ compilation. It's just calling this stuff directly. And so that's what this is fundamentally about. So you're probably thinking at this point, let's pause for a moment and just recap what we've done. We started off with FFI. We were able to use it to do some fun console stuff. Then we took it and did some things like message boxes and like simple Windows apps. And then we started using it to do COM and do all these other kind of crazy things. And you might be thinking at this point, wow, like there's thousands of lines of code here. And again, if you remember that kernel32 file, that's a huge file. And there's like thousands upon thousands of these. You might be thinking, well, did Tim really write all this stuff by hand? Is he really like that? He needs help. We should sort of figure out a way of like helping him out here if this is what he does for his evenings and weekends. And of course the answer is no. I didn't handcraft all this code. And so, well, you're probably thinking, well, then how do you go about doing this? It turns out if you've got a C library of your own, there's a package that we have called FFI Gen. And FFI Gen basically takes headers and it creates these mappings for you. Unfortunately, it doesn't work great for Windows code because when you're looking at things like COM things, there's a lot of inbuilt sort of like knowledge about the way that Windows works that makes it not produce super idiomatic sort of Dart code. Fortunately, Microsoft, around a year or so ago, came out with a new project called Win32 Metadata. And the idea of this project was to take all of the Windows APIs and provide a nice database that contains like all of the information you need to know about all the API calls that are available. And they wrapped this database up in this really bizarre format. I'm not going to kind of speculate as to why. It's Microsoft. But they use this standard called ECMA 335, which is an 800-page document to describe the binary format of this database. It's just hideous. My copy of this book is very thumbed through because I've had to figure it all out. But anyway, there is this like standard for how you go about accessing this metadata. There are also utilities you can use. So there's this thing called ILSpy that lets you sort of browse into this database, and you can see the kind of thing that it spits out. Here's a list of thousands of API calls, and they are at least nicely structured in a hierarchical tree, and then you can see like all the metadata associated with these. But that's not super helpful to me either, because I wanted to do things from Dart. Turns out that there's a COM component that lets you talk to this database and call things. So it's a little bit of a kind of a bootstrapping problem. But if you can create the code to call the COM component, you can access the database that's got all the data about all the COM components and all the other APIs that you might want to call. So that's what I did. I created this thing called WinMD. And what WinMD does is it provides a single sort of idiomatic sort of wrapper around the whole metadata sort of processing. And you see here loads and loads of methods that sort of this does that lets you find methods and parameters and signatures and a whole bunch of stuff that I'm not going to go into right now. But this is a COM component. It's got these two main interfaces here, iMetadata import and iMetadata import 2, just when you thought it was safe to import metadata. And so that's what I took and used here. So if I go for a moment, let's go back again into Dart code. And let's just go here. And where did I put it? Here, WinMD. Let's open this one real quick. This just shows you how to use this metadata tool. So here I've got this package WinMD. This is my package for accessing Windows metadata, and I can say give me all the Win32 metadata, and then I can say now browse to this bit of the metadata tree, which is essentially the core Windows messaging APIs. And this function here simply goes through and it gives me like here's the nasty gnarly code behind the scenes that calls all these COM components, but you don't need to worry about that. It'll just give me a list of all these functions. So if I go here and call WinMD, example.dart, you'll see this in action. And there's something like 500 methods in this particular one here, and you can see here's a list of all these methods. So this gives me everything that I need. And if you attended Anna Lushchenko's talk yesterday on Build Runner, you'll know like there are ways to do code generation. And so I use this to generate the Dart code that you see in that kernel 32 DLL. And so I won't browse through that in detail, but that's all in there, and there's a whole bunch of fun things there. lastly, we're running out of time, so I want to kind of skip forward a little bit and talk about the next layer on the Windows world. So I've talked about Win32, I've talked about COM, and then in Windows 8, Microsoft introduced yet another programming interface, which was used for all the latest, most modern APIs, including UWP and things like that, and that's called WinRT, or Windows Runtime. And WinRT extends COM. If you know COM, you already know a lot about WinRT, but it extends COM with things like generics and callbacks. What else does it include? A whole bunch of other sort of properties and sort of things that are sort of, again, sort of a more modern way of writing object-orientated code. And in the WinRT world, every object is not just an unknown. Every object also supports this second interface called IInspectable, which basically lets you kind of get information about those objects. So now you've got something that you can use to build these more sophisticated things, which suddenly makes Win32 need to do a whole bunch extra work, because now Win32 has to be able to model properties and callbacks and generics and overloads and async and events and things like that. And so the credit here belongs to somebody else. There's a Turkish developer who suddenly just showed up on my GitHub project, and this is the magic of open source. A Turkish guy called Halil Ibrahim Durmuş. Thank you for help. Somebody earlier on told me how to pronounce his name. He has been really helpful with this super complex WinRT stuff that is way beyond my skills as a humble product manager. But using this, you can now go and use all the latest WinRT functions as well. So if I go back to the example here, let's just grab calendar just as an example here. And this is an example of WinRT code here. So this is calling the Windows 8 and above calendar methods that let me do things like sort of find the current calendar, find the Japanese calendar, the Hebrew calendar, and compare and contrast these different things using the system. So if I go and call this one, let's go and call dark calendar. You'll see an example of this in action. So here I'm taking the standard sort of English calendar. Today is the 1st of September. I'm currently in Central European time, and it basically, this code says change the calendar system to the Japanese calendar system, and then tell me what the date is. And so you can see, there's the Japanese version, and then here's the Hebrew version. And this is all the power of Windows now available to you as a developer. So again, if you're writing a package or an application and you need to be able to do anything that Windows makes available, with a few minor exceptions at the moment, this package lets you get in and do all of that kind of really cool stuff. So credit to Halil for taking this beyond my skills. Very last thing I want to show you. So everything I've done to date has been Dart. It's not really Flutter, it's all been Dart. But when you write Flutter code, if I go and let's just say I'm going to go back to here and let's create a dummy application here. I'm going to go and do Flutter create. It's going to call, pull down the dependencies and create me a folder structure. Here's what you can normally get, right? You get a whole bunch of folders, and the bottom one there is a folder called Windows, and that's the magic that lets me run Flutter run when I call an app like this, and make everything happen. If I actually go in and look at this package here, normally we avoid those folders like the plague, right? We normally kind of go into lib and we sort of write code around here. But if you bury yourself down in here, you'll see that there's code that actually does the magic of loading the window here. And so this is C++ code in every single Flutter project today that does the same stuff that I was talking about earlier on. It handles this message handler. It deals with creating and closing windows. There's a whole bunch of sort of stuff here that is associated with setting up windows. And there's that message loop, if you remember, that I showed you in Dart earlier on. That's the C++ version that gets compiled into every Windows app that you build with Flutter today. So I kind of thought, well, it'd be kind of nice if I could do that in Dart. So I spent a little bit of time just playing around and sort of essentially taking this C++ code and translating it to Dart. So I'm going to go back to, where are we? Win32 counter. And this folder is, just to be clear, I just did exactly the same thing. I just did Flutter create. I didn't do anything else sort of super magic with it. But notice there's no Windows folder here. I just deleted the Windows folder altogether. So this is just Dart code in this package folder here that you see. No Windows code, no C++ or anything like that going on. This is just pure pure Dart goodness. When you take that code, if you do a little bit of tweaking, you can actually go ahead and use a package that I created to produce that same C++ code in Dart. And so that's what this little bit of code has in this kind of stub. You could add this bin folder to any Flutter app that doesn't use plugins for various reasons. This does all that same magic work. And so now if I run this, I've got a little thing called compile.cmd. And what this does is it calls some Flutter commands to go and take this all together, the bin folder and the lib folder, which contains my sort of standard functions here. And you'll see that this is calling Flutter assemble. It's saying I'm targeting a release version, I'm targeting the x64 device, and just going to put all this stuff together. Again, there is to be very clear, there's no C++ code in this folder, and I don't even have Visual Studio installed on this machine. So I don't even have a C++ compiler in the VM that I'm running here. This is just Dart code here. And so it's taking it, it's assembling it, it's compiling it, and now I have this thing called counter.exe. And this is a pure Dart Flutter application. So the loader, everything else that's going on here is Dart. I can go ahead and I can run this, and I can do all the usual things that I do from a counter application without needing to have Visual Studio on my machine, without having to have Visual Studio license, without having to go through all that make and CMake and all the other random C++ stuff. It's just pure Dart code there. So, closing out, lots of stuff that we've talked about today. Win32 is the package that lets you access all of this Dart stuff. Dart Console is the package that lets you do console stuff on Windows or other platforms. And now over time, it's been really fun to see a whole swathe of other Windows packages or other packages pop up that are using the Win32 code that has been written here. So now things like File Picker or Biometrics or Path Provider, those are all using the Win32 package to do all that sort of complex stuff. So you don't have to worry about all the crazy things that we've talked about this morning. You can just call File Picker, and it under the scenes will do all of that work for you, but it will do it all using Dart. And so a whole bunch of those fun different packages that are out there, you can take and play with them yourself. So to close out, it's over to you. I'd love to see you writing Windows apps with Dart and Flutter. Of course, we all want to see tons of apps that are out there. I'd love to see packages that use this Win32 stuff. The more packages that are built using Win32, the less likelihood it is that somebody needs Visual Studio and all those other things to be able to create a Windows app. Maybe in a future world, all of the packages that are out there for Windows will use just pure Dart code, and then this will be available and we can actually create everything just purely using Dart. And thirdly, like Halil did, I'd love to encourage you to contribute to Win32, whether it's contributing code, contributing bugs, contributing questions about how to use it, because that helps me make the project better for others to use. So that's it all. Thank you very much.